Okay.
Here's the code for the FM receiver. As you can see, every GNU radio have to use the Python to execute the file. We import the libraries from the GNU radio. We import the system, the math, and the WX in order to process the signal. So in this part, we try to get information from the user. For example, the Ethernet, the MAC address of the USRP2 is connected to, the frequency that you want to send, that you want to receive the signal, the gain, and also the volume that you want to set. After define all the parameters for the user to set, you will after the user input his wanted parameters, you will get the parameters from the command, check for any errors, and then set frame, set panel, and set the volume, the state, and the frequency. Here, as I introduced you before, we set the USRP2 at the source with the option interface, as you can see here, the option interface and the option MAC address, as you can see here. Right now, I will set with the USRP2, the ADC rate is 100 megasample per second. So I want to decrease the data rate to a slower data flow. So I have to set the USRP decimation rate. Here I set it to 230. So, and then I set the decimation rate for the USRP2 by the command self.u.set_decim with the parameter USRP decimation is here. And after that, I calculate the USRP rate here. I calculate here. In this case, I set the USRP decimation rate to 230. It means that this number must be 440.1 kilosample per 441 kilosample per second. And this data will go straight through the gigabit Ethernet, and then at the filter, at the low pass filter, I set the decimation rate is 1. It means that I will keep the speed of the data stream at 441 kilosample per second. And then at the output, I set the audio decimation rate is 10. It means that the data will go to the data goes to the speaker headers, go to the sound card. We have the speed of 44.1 kilohertz. In this block, I will detect the daughter board I use in the US with the USRP2 because the FM is transmitted at the frequency 100.1 megahertz. But here, because I just want to make sure that the daughter board will support these daughter boards, will support that frequency. So I have to check it out. And if the daughter board does not cover the required frequency range, here we have 100. The FM signal is 100.1 megahertz. So I will print out the daughter board does not cover the required frequency range. And if I still want to use that kind of daughter board, I have to press enter. The daughter board, the data from the USRP2 will go to the low pass filter. Here I set the low pass filter by using the OPT filter with the gain is 1. The USRP rate, as you can see here, is 230, and the passband cutoff. The passband cutoff and the stop band cutoff. With the passband width is set to 0.1 and stop band attenuation is 60. This is the vector with the length of about 19, and then after you have the vector of the low pass filter, you put it here with the channel filter decimation as you set here. You'll get the filter for you. And also here we define the central processing block for the FM receiver. In this block, we will process the data that get out from the low pass filter, and then after the data out of this block, the guts block, we go to the volume control. Now we set the volume of the audio, and here we define the audio sync. Here we define the audio sync with the audio rate. Here, as you can see, that 44.1 kilohertz. And after defining all the parameters and for the blocks, you connect them together. First thing at the very left, because I use the USRP2 and the source, I had to put it at the left of the command. I connect the USRP2 with the filter and with the central processing block, and then I connect them with the volume control part, and then I connect it to the audio sync. Here the audio sync is the sound card, and I connect the sound card with the speaker. And here these blocks are used to define the gain. In this guy, if no gain was specified, if the user don't have any idea about the gain, then we can get the range from the range that the daughter board support, and then we make the average of the gain, and also we set the volume. And if the frequency that we define here, if the frequency I make the default here is 100.1, which is far more smaller than 100.1 megahertz, and if the user don't have the specific frequency, so the frequency is set at the default, that is 100.1, and we will multiple that number with 10 to the 6th to get the 100.1 megahertz. And we will set gain and set volume for the system. in this block, we are setting up parameters for the FFT, and then at the end, instead of connect the the central processing block for the FM receiver with the audio, we also connect it with the FFT in order to display it. Here, in this block, we set the frequency. We will set the frequency for the USRP2. The previous one, it means that we define the frequency for the USRP2, but this block is used to set the frequency for the USRP2. We also set the gain and all the other parameters here. So after have all the parameters for the system and we connect them together, at the end of the code we try to run the code here. So if the name of the program is main, it means that you run the program and the name will be the main. Then the software will run the SD guide 2 and then go straight to the main loop. Is similar with the code that I presented to you before. Here, as you can see. So right now, I will use two computers. One is used as the transmitter. I'm trying to transmit a music file, and the other computer will be used as the receiver. I'm trying to receive the signal from the transmitter and decode the demodulation the signal, and then put it on the FFT and the speaker so you can hear the voice.